Hello, class. Today we're going to be talking about the chords and circles and how they all tie together. A couple of things I need to talk about before we move on. A couple of probably new terms or terms that you have forgotten. So the word chord, what does it mean in the context of math and especially circles? So a chord is a line segment that joins 2 points on a circle. Oops, I missed the S here. 2 points on a circle. So if you have a circle right here, so it shows you where the chord is. So any 2 points on a circle, if you connect them with a line, that would make it a chord. That makes the diameter have a better definition now that we know what a chord is. So the diameter is a chord that passes through the center of a circle. So if you have 2 points on the circle and you connect them, and that line goes through the center of the circle, that would give you the diameter. Okay, so obviously the diameter is important. We have a lot of uses for it. So it's double the radius and all that other stuff. Bisect, what does bisect mean? Bisect means divides a line in math usually, or any object. To be honest, you can bisect a snake, I guess. Anyway, for a line, you bisect it by cutting it in half to equal parts. Perpendicular line is a line that forms a 90-degree angle with the line it intersects. So I drew 2 lines here. So this would be a 90-degree angle. You can compare it to the grid behind it. For these 2 lines here, this is not a perpendicular line, because if you compare it to the grid behind it also, where you have 90 degrees between the grid lines, the vertical and the horizontal, you see that this one is obviously different. So of course the perpendicular, we draw our symbol for it, which is a little square at the corner, and for this one here we have an acute angle and an obtuse angle on the side right there. Okay, so that's important. So we can talk about the theorems that we have here, or the properties of perpendicular to chord. So this is property 1. No, I got mixed up a bit. So perpendicular to chord, property 1. So this one here reads, the perpendicular from the center of a circle to a chord bisects the chord. So we have this drawing right here. We have a circle. This is the center of the circle, and here we have a chord because we have points A and B joined together. So if you draw a line from the center of the circle to the chord, that line would cut the chord in half, and it will have a 90-degree angle with that chord. That's very important. Has a lot of uses if you talk about space exploration and orbitals and a lot of different. Also, when you talk about small things like atoms and electrons orbiting the atoms and all that stuff you guys studied in science class this year, that has a lot to do with it once you, of course, study it further in deeper details. So we're here. Okay, the chord bisects that in perpendicular divided into equal parts. So point O is the center of the circle. So when OCB equals OCA, so if those angles are the same and equal 90, then AC equals CB. So AC equals CB. So in these theorems, perpendicular to chord properties, they're gonna write them in 3 different ways, but they'll be talking about the same thing. So you just need to read them carefully. So again, here the perpendicular to the center of a circle. So if they're saying here, if this line is, if this angle is 90 degrees, that means those 2 sections are equal. So it bisects it. The other property, property 2, it says the perpendicular bisector of a chord in a circle passes through the center of the circle. So here they're working backwards. So if you have a chord and then you draw a line that bisects it and is at 90 degrees angle, that line will go through the center. So really, in this case, if you're looking for the center of the circle, you can have a chord on a circle, and you draw a perpendicular line to that chord straight out, and that line would go through the center of the circle. So again, they're all the same thing, but it depends on what is your starting point and how you can find it. So here you can find the center of the circle from a chord. The next property, or the last one that we're going to be talking about, property 3, it says a line that joins the center of a circle and the midpoint of a chord is perpendicular to the chord. So here they say you already have a chord, you have a line that bisects the chord, and it goes through the center. If that's all true, then this line is going to be at 90 degrees angle, but they're all saying again the same thing. All 3 properties, but just the same thing. You have a chord and a line coming from the center. So that line would bisect the chord, and it would make a 90-degree angle with that chord as well. Okay, so let's see how we can use that in problem solving. So in this example right here, it says determining the measure of angles in a triangle. Example number 1 from your book. So point O is the center of a circle here, given information, and the line segment OC bisects AB, and they also give you angle OAC. So that angle OAC right here is 33 degrees. Determine the value of X and Y. So X is right here, Y is right there. So a couple of things here. First thing you need to look at is the sides, those sides right here. OB and OA. What would you call this? What would you call a line that goes from the center of a circle to any point of the circle? A lot of people would say this is the radius. So this is information here. We don't know how it's going to be useful, but the radius of a circle is always going to be the same. You can draw an unlimited number of radii or radiuses, the proper way is radii, to a circle, and all of them will have the same measurement, the same length. So that tells us that this triangle, the big triangle, AOB, so AOB, triangle AOB is isosceles. I don't know how to spell this. I hope I spelled this correctly here. Isosceles. So that's one piece of information. Let's look at what does that. Well, here we go. So now the wheels are turning. So if that is the case, what do we know about isosceles triangles? They have the angles or the opposite angles are equal. So angle 33 and angle X are going to be the same. We can say therefore X equals 33 degrees. Okay, because this is an isosceles triangle. So we solved the X problem. So now what we're looking for is Y. From property, so now let's look at which property would that be useful. So we know this is a chord, and we know that this line OC is goes through the center of the circle. So which of these properties would work? So that would be property 3. Because property 3 tells you if you have a chord and it's bisected by a line that goes from the center of the circle to the chord, that means this angle is 90 degrees. So we know now angle, so the angle OCA equals 90 degrees according to property of chord. What is it? Oops. To perpendicular to chord. I'm just gonna write it there. Shorthand, perpendicular to chord property 3. Okay, so that is a 90 degrees. Why is that useful? Now we know that y plus 90 plus 33 equals 180. It's a triangle, so all of its angles add up to 180. So that tells you that y equals 180 minus 123, which gives you 57 degrees. So 57 degrees is the measurement for this angle at y. Okay, and I think we have one more example before we're finished. Here, using the Pythagorean theorem in a circle, you have point O is the center of a circle. AB is the diameter with length 26. So here we have 26. CD is a chord that is 10 centimeters from the center of the circle. So this here is a chord, and this length right here is 10 centimeters. Give the answer to the nearest tenth. Okay, what is the length for CD? So what they're looking for is CD, the length of the chord. Okay, let's see how that is important. Okay, I think now we know. Okay, so a bunch of information given to us right here. One thing that you need to know, I guess, is what is 26? What would you call 26? So AB, whoops. So AB, so that it's a chord really, but it has a special kind. What special kind is the diameter, right? So that's the diameter, and it's 26. Why is that important? That means OB equals 26 divided by 2, or 13, because OB is a radius and the radius is half the diameter. So that is an important piece of information. Why? Because now you can draw a radius from the center of the circle to any of the points. You can do one here, so you can say OD, or you can say OC. So I would draw OC or OD. Why is that important? Because we know the length right here, OC and OD, both of them are 13 centimeters, because it's a radius, and we established that the radius is 13 centimeters, or half the radius, the diameter. So 13 centimeters. Now we can use the Pythagorean theorem. So the hypotenuse is 13. We have one of the legs is 10, so we can find the other leg, CE, is the unknown number 1. So I'm gonna be using OC. OC is hypotenuse, and I will say in hypotenuse is C, and the length OE is, I'm gonna call it A. You can call it B or whatever you want. So we need to find CE now. CE is what we need to find. Okay, which C in this case is B. So to solve this, we have A squared plus B squared equals C squared. That does not change. So A squared, so we have, this is C, this is A, and this is B. Okay, so we have 10 squared plus B squared, which is unknown, that remains as B squared, and C squared is going to be 13 squared. 10 squared is 100, 13 squared is 169. Always use a calculator to double check. So 169. B squared is equal to 169 minus 100. B squared equals 69. So now, of course, we need to take the square root of both sides. So B is gonna be 8 point what? 69. Oops. Square root of 69 is 8.3. 8.306, whatever. So that rounds to the nearest tenth, and we have 8.3 centimeters. Okay, so what are they asking for? They're asking for CD, not for CE. Okay, CD. So if this is 8.3, that means ED is 8.3. So CD equals, you can say 2 times CE, or you can draw it, I don't really care how you show me this, but CD will be 8.3 plus 8.3, which is 16.6 centimeters. Okay, that's it.